All right, for the end of this chapter, end of this section 2, we will talk about the classification of matter. The first part of this section, we talked about compounds versus elements, and that all elements have identical atoms, and that compounds can be two or more elements put together, but they're put together chemically. So they're chemically joined with a bond. And that's where over here you can see it cannot be decomposed by ordinary chemical means. That means by physical means like evaporating it, boiling it, or just smashing it, you can't get it done. So you need to have enough energy to break them apart. Mixtures, however, if the composition is uniform, then you would have a homogeneous mixture. And that means it would be same throughout. So uniformity is everybody is the same. Homogeneous in mixtures means that anywhere you look in that mixture, there will be the same amount and same consistency. So air, there is an oxygen higher in the atmosphere and, in the classroom, and then less oxygen lower, but there is an equal mixture of air in the classroom. Sugar in water. Now we all know we can add so much sugar that it'll pool up or pile up at the bottom, but if you add sugar to water and you stir it in and you don't over add the sugar, it will mix evenly throughout. So at the top of the water, it will be just the same amount of sugar as at the bottom. Stainless steel is also a mixture. That would be an alloy that would have the same equal consistency of every metal that's mixed in there. Heterogeneous mixtures, however, are not evenly mixed, and I would give you an example of oil and water as a heterogeneous mixture. They're just going to be opposites. There's not going to be an even mixing of those. These are also 3 good examples, granite, wood, and blood, but a better visual for that I like is a salad. You have a lettuce and you have some spinach, so there's 2 different things. And then you have tomatoes and cucumbers and maybe some croutons and bacon bits. You look at that salad, that stuff is not going to be mixed evenly throughout. There's going to be kind of layers. The tomatoes will be clumped up around and cucumbers. So it isn't evenly mixed throughout. So when we look at those, this visual concept is just going to explain just what I explained, so we're skipping it. So if we look at this, pure substances, part of matter, are going to be one kind of atom or one kind of molecule. And so they give you elements and compounds as our examples of pure substances. Mixtures, there's 2 kinds of mixtures, homogeneous and heterogeneous. And if we look at these words, homo and hetero, or these prefixes, homo means the same. And we said it would be the same throughout or uniform throughout. Heterogeneous mixtures, however, like heterosexuals, that's a male and a female, they're different. So we would have 2 different layers. And if you look at this example, sand and water, the sand is pooled up at the bottom and the water will be at the top. And that would be how oil and water would be as well. So hetero, different, homo, same. Classification. So a mixture, being the blend of the 2 or more kinds of matter, each will retain their own properties. You can mix them together physically, but you can also separate them. So if you have salt water or sugar water, you can evaporate off the water and you'll be left with the sugar or salt behind. Homogeneous mixtures are called solutions. Homo meaning the same throughout. Homogeneous mixtures are uniform. Heterogeneous mixtures are not uniform. So I've emphasized this. We've said it several times now. Homo, same. So it'll be the same throughout. Hetero, different. And there'll be different layers, or you'll be able to see the differences in the substances in it. Sugar water, silicon dioxide water. Oops, forgot. So pure substances have a fixed composition. That would be your compounds and elements. And we said, like water is H2O. It has to be 2 hydrogen to every 1 oxygen. And so elements also are exact. You have atoms of an element, they are all the same, and they would be equal throughout, and they are the same. So every sample of a given pure substance has exactly the same characteristic properties. Every sample of a given pure substance has exactly the same composition. Water is always 11.2% hydrogen and 88% oxygen by mass. And hopefully we'll have showed you that on Friday before you've watched this lecture. In some of the chemicals that we have in the lab, there will be impurities, and it will give you those impurities on the bottle. And we will also have looked at this in the lab. So what I've shown you, what you're seeing in lecture, hopefully you've seen in class. I've given you some examples. Now you can pause this on here and read through these examples. Iced tea, stainless steel, and maple syrup. Orange juice is heterogeneous because if you think of the pulp, that pulp will settle out or it's floating around there, so there's something in there that is not right or equal or uniform. Chocolate chip cookies, chocolate chip pecan cookies. Granite, if you remember the rocks that you studied in earth science, granite has different components within it. Salad was my example. Section 3. Use the periodic table to name the elements, given the symbols. Write the symbols, given the names. Describe the arrangement of the periodic table, and then list the characteristics that would distinguish metals, nonmetals, and metalloids. We're just getting a basic idea or basic view of the periodic table. So here are some different names of elements. Antimony, Sb, stibium. We had old names, and that's where we got the symbols from. And so now we just use these symbols even though the names are not anywhere close to what they would be. Now copper, I want to point out there is cupric and cuprous compound. Excuse me. Cuprous and cupric compounds. So when you read those on the jars, you have to be aware of that. Gold, iron, sometimes we'll see iron, the ferric compounds, ferric oxide and ferrous oxide, and we'll talk about the difference of those. So sometimes these names are actually the names that you'll find when they are in a compound. Now, on a periodic table, we have groups. So group 1, group 2, group 3, group 4, 5, 6, and so on, all the way to group 18. In some periodic tables, you'll see Roman numerals being used. Okay, we're, like this is Roman numeral 7. We are going to stick with the 1 through 18 for our purposes. On the sides here, this number 1, these are the periods. Period 2, period 3, period 4, 5, 6, and 7. Now these items down here, 58. If you look at this number 58, atomic number 58, and if you look, this follows, it should fit in between here, 58 through 71. And there is 57 and a skip all the way to 72. Same thing for this group down here. It fits right between 89 and 104. These down here, and we'll get more into this, have different properties than they fit into. These have similar properties altogether, but different properties than what would be around them up here, and so they are pulled out. Otherwise, you would have to extend the periodic table and squish them in, and it would just make the periodic table look goofy. So that's how those work. So on the periodic table, just as I said, the vertical columns are groups, and when they have special names, they are called a family. So we have halogen family, we have the alkaline metals, the alkali metals, and we have the noble gas family. So we'll get more into the family names, and we'll learn one this chapter. The horizontal rows are called periods. Physical and chemical properties change as you go across a period. As you go down a group, the properties will stay the same. So as we go down a group, properties are similar. As you go across, we are slowly going from being metal properties to non-metal properties. A metal, then, is an element that is a good electrical conductor and good heat conductor. I hope you have known that in the past, and that's just review. Another property of metals are that they are solids at room temperature for the most part. The one that is not is mercury. They are malleable, so they can be hammered or rolled into sheets, and they have ductility, or they are ductile, which means they can be drawn into a fine wire. And then lastly, they conduct electricity and heat well, so they're good conductors is what we would call these. These are examples of metals, of course. Then non-metals. Sorry about that, my mouse doesn't work so well. Non-metals, they are poor conductors of heat and electricity. So non-metals do not conduct heat and electricity. That's why we use wooden spoons or plastic spoons to stir with so that we don't burn ourselves. Properties of metals. Many are gases, although some are solids, and they are brittle. If they are a solid, they are brittle, whereas metals are malleable and ductile. Solid nonmetals are brittle, meaning you hit them, they'll break into pieces. And then, of course, they are poor conductors. Types of elements: carbon, sulfur, phosphorus, and iodine. We will have already looked at these in class. Metalloids, these are the ones that are between the metals and the nonmetals on the periodic table. You can find them on a stair-step line between them. And obviously, if you have this metalloid name, that means it's not quite a metal and it's not quite a nonmetal. It's something in between. So properties of metalloids: they are solids at room temperature and semiconductors of electricity. So they will conduct under certain conditions. Types of elements. Oh, we got one more I got to get here. Noble gases. Like I told you, we were going to do one family, if I can get my mouse to work. One family, and we'll talk about the noble gas family. This is group 18 of the periodic table, and they're generally unreactive. And they used to be called the inert elements because inert meant not reactive. But we have found that some of them are reactive under certain conditions. So they're generally unreactive, not completely. And they are gases at room temperature. So the noble gas family is the only one we're talking about in this chapter, but there are other ones. And that concludes this chapter lecture. And that is end of section 3 and the end of chapter. So what I would like you to do is the chapter 1 review. Go to the link for the review, play those games, and I will have taught you how to do a screenshot of your game while you're playing it, and you'll also record your scores. So we'll talk about that tomorrow and get you all ready for that. Have a good weekend.